Good morning. I'm Lakeisha Johnson, and today I'm excited to share my APE or Applied Practice Experience project titled Tracking the Pulse of Survivorship HRV as a Public Health Indicator of Physiological Stress. This project combines data analysis and program design to explore how heart rate variability, or HRV, can enhance care for older adults living with cancer. Please note that this presentation offers a summary of my APE project, and full data and detailed analysis are available in the final written report. This APE was completed in collaboration with the University of Maryland, Baltimore School of Nursing under the mentorship of Dr. Amber Kleckner, while the broader clinical trial is examining time-restricted eating, or TRE, in individuals with prostate or metastatic breast cancer. My work focused specifically on HRV as a physiological marker of stress and recovery in cancer survivors. Over a 12-week period, participants completed baseline and follow-up assessments, including HRV measurements, blood pressure, glucose, gait speed, and symptom surveys. My role was to lead the HRV analysis to better understand how the autonomic nervous system responds to chronic illness and survivorship. Ultimately, this project aimed to inform more personalized, data-driven strategies to support the long-term well-being of older adults living with cancer. This project took place at the University of Maryland School of Nursing, specifically within the Pain and Translational Symptom Science Department, also known as PTSS. I worked under the guidance of Dr. Kleckner, who leads a clinical trial examining the effects of TRE and people living with cancer. And again, while the broader trial includes many components, my APE focused specifically on HRV data. As the APE student, I led the analysis of electrocardiogram, or ECG data, to assess HRV. I used Cubio software to identify R wave peaks and extract key physiological metrics, which reflects autonomic nervous system balance. My goal was to explore how HRV relates to chronic illness burden and physiological stress, ultimately helping us understand how data like this can support more personalized, equitable survivorship care. For my APE, I completed two major work products that build on each other. The first was a comprehensive HRV data analysis report where I examined baseline and 12-week HRV metrics to understand how physiological stress correlates with chronic illness burden among older cancer survivors. This helped identify patterns that could support more personalized care strategies. And the second product was the development of an HRV-focused public health program called PulseCheck. This 12-week wellness intervention uses HRV as a real-time biomarker to guide symptom tracking and stress management. It translates the data insights into a scalable, survivor-centered program that supports resilience and recovery. So now, let's talk about the connection to CEPH competencies. This APE gave me the opportunity to apply a range of public health competencies in a real-world research setting. First, on the competency C3 data analysis, I cleaned and analyzed HRV data using Cubio's and statistical software, applying both baseline and longitudinal approaches to explore individual variability and group trends. Through competency C4, interpretation of results, I translated statistical findings into meaningful insights about autonomic imbalance using HRV metrics like SDNN and PNS-SNS indices to understand physiological stress in cancer survivors. Competency C7, population needs assessment, was addressed as I evaluated patterns of dysregulation and symptom burden among older adults living with cancer, helping identify unmet needs in survivorship care. Next, C9, intervention design, came to life through the development of the PulseCheck health program, which uses real-life HRV data to guide personalized strategies for stress management and recovery. And finally, for C19, public health communication, I created clear visuals, written reports, and program materials designed to make biometric data understandable and useful for both clinical teams and survivors. Together, these competencies helped shape a project that's not only grounded in data, but also responsive to human experience and public health impact. So what were my APE activities? Well, as part of my APE, I collaborated with Dr. Amber Kleckner and the research team at the University of Maryland School of Nursing. Inputs for this work included ECG recordings, patient-reported symptom surveys, statistical software, and ongoing mentorship. My core activities involved cleaning and processing ECG data, identifying R-wave peaks, and extracting heart rate variability metrics such as SDNN, mean heart rate, and autonomic indices using Kubio software. These efforts led to two key outputs, the HRV data report and the PulseCheck wellness program proposal, both centered on advancing personalized care for older cancer survivors. This work was developed in alignment with the larger clinical study, implemented with careful attention to data integrity, and adjusted based on individual variability and feedback from my mentor. I regularly reviewed outputs for scientific accuracy and practical relevance to public health. In total, I logged over 120 hours on this project, gaining valuable experience in data analysis, intervention design, and cross-disciplinary research, all while staying grounded in public health equity and person-centered care. This project had three main goals. First, it was to assess associations between HRV indicators and health factors like age, body mass index or BMI, and chronic illness. Second, to track HRV changes over 12 weeks. And three, to explore HRV's role in personalized care planning for cancer survivors. We hypothesized that lower HRV, especially the SDNN, would be associated with greater chronic illness burden, higher BMI, older age, and longer duration since diagnosis. These factors are known to affect autonomic regulation and stress. So why does HRV matter? As cancer treatments improve, survivorship has increased, but so have the long-term side effects. In 2016, over 60% of cancer survivors in the US were over 65. By 2040, that number is expected to rise to 73%. These individuals face fatigue, comorbidities, and physiological strain. HRV offers a non-invasive way to detect stress in real time, filling gaps that self-reported symptoms can miss. Now that we know why HRV matters, let's discuss a little background on HRV. HRV measures the variation in the time between heartbeats and reflects how well the autonomic nervous system manages stress and recovery. Higher HRV indicates better adaptability, while lower HRV can signal underlying strain. Key markers include standard deviation of NN intervals, or SDNN, which is a global indicator of autonomic function, mean heart rate, or mean HR, which can show elevated stress, and parasympathetic and sympathetic nervous system indices, and these will be referred to as PNS or SNS respectively, which reflect parasympathetic and sympathetic balance. Together, these markers provide insight into hidden physiological stress in cancer survivors. To carry out this project, we recruited and analyzed ECG data from 20 older adults participating in a 12-week trial. 9 of the participants were assessed at baseline and at week 12. Using Kubio software, we extracted SDNN, mean heart rate, and PNS, SNS indices. We also gathered self-reported chronic illness data and used linear regression and Pearson correlations to explore associations. Now that we know what we've done, let's talk about what we found. While the results were not statistically significant, important patterns emerged, such as lower SDNN in those with longer care history and higher BMI, decreased parasympathetic activity, an elevated heart rate, and strong inverse correlations with sympathetic activity. These trends suggest HRV can reveal hidden autonomic strain in cancer survivors. Given our key findings, we concluded that HRV, especially SDNN, holds promise as a marker of physiological stress. Even in a small sample, we saw meaningful trends, though further research with more diverse participants is needed to confirm HRV's role in enhancing survivorship care. The public health implications are: HRV is scalable, non-invasive, and actionable. It can detect stress early, personalize care, improve equity and access for older adults, and enhance quality of life in survivorship care. So my APE led to the creation of an HRV-focused health program called PulseCheck. PulseCheck is a 12-week public health initiative for older cancer survivors. It includes weekly HRV tracking, resilience coaching, and stress reduction strategies tailored to individual needs. PulseCheck is grounded in SMART objectives. The program focuses on improving SDNN and balancing autonomic function. We'll track participation, HRV trends, and self-reported outcomes over 12 weeks. Let's now discuss the implementation and evaluation. The 12-week program includes participant recruitment, onboarding, and continuous monitoring, with approximately 2 weeks of evaluation. We'll evaluate impact using HRV metrics and surveys. The goal is to empower survivors with tools for proactive self-care. So what's the public health impact of the program? PulseCheck supports a person-centered, data-driven model. It offers real-time insight, improved care planning, better management of chronic stress, and a pathway to more equitable cancer care. So, what's the takeaway from all of this? I'd say the takeaway is this project laid the foundation for a scalable HRV-informed program. PulseCheck offers a unique blend of real-time data, personalized care, and community outreach. Its ultimate goal is to fill the gap in survivorship care with tools that are proactive, measurable, and equitable. So now, how can I reflect on this APE? Well, this APE really brought my public health training to life. Working directly with real-world HRV data in a clinical research setting challenged me to think critically, problem solve, and communicate findings in meaningful ways. It wasn't just about numbers. It was about seeing the people behind the data and asking, how can we better support them? I strengthened my technical skills, but I also grew in confidence as a practitioner. This experience showed me the power of using data to drive equity-centered solutions, and it reminded me why I'm passionate about public health, because behind every graph is a person, and every intervention is a chance to make their care more responsive and human. I would like to extend a huge thank you to Dr. Amber Kleckner and Karen Klingen from the University of Maryland School of Nursing for their continued support and guidance throughout this project. And also thank you to both institutions for allowing me to pursue my MPH. That is the University of Maryland Baltimore School of Nursing and the Eastern Washington University.